panel in question is required to be bonded to building steel because it functions as a separately derived system with a single-phase 200 amp service. The National Electrical Code, specifically Article 250.30, A, mandates bonding for separately derived systems and service equipment that operate over 150 volts to ground. The location of the bonding conductor is critical for ensuring effective grounding. It should be positioned as close as possible to the service equipment, which in this case is the 200 amp breaker located at the back of the building. This proximity helps to minimize the impedance of the bonding path, thereby maximizing the effectiveness of the bonding. Regarding the use of a second ground rod, NEC 250.53 A3 permits the installation of a second ground rod if it is effectively connected to the original ground rod and driven into permanently moist earth. However, in this scenario, a second ground rod is not strictly necessary, given that there is already an existing ground rod at the breaker location. It is important to understand that the primary function of bonding the neutral bar to building steel is not to create a backup grounded conductor. The National Electrical Code does not stipulate the need for a backup grounded conductor for a separately derived system, provided that the system is appropriately bonded to building steel. The action of bonding the neutral bar to building steel at the problem panel is, based on the information provided, a correct measure. This step aligns with the NEC requirements for bonding separately derived systems and establishes a low impedance bonding path, which is essential for safety and proper system operation. Further recommendations would include verifying that the ground rod at the exterior breaker is securely connected and exhibits low resistance. It is also advisable to conduct a thorough inspection of the entire electrical distribution system to ensure proper grounding and bonding. This inspection should encompass building steel and cold water bonds. Finally, installing a surge protective device at the main breaker is worth considering, as this can protect the treadmills from potential electrical surges that could damage sensitive electronic components. To further clarify the importance of proper bonding and grounding, let's delve deeper into the technical aspects and code requirements. Separately derived systems, such as the one feeding the treadmills, require special attention because they introduce a new source of power that is electrically isolated from the main service. This isolation necessitates the establishment of a dedicated grounding system to ensure that fault currents can be safely conducted back to the source, tripping circuit breakers or fuses and preventing electrical shock hazards. Article 250 of the National Electrical Code provides comprehensive guidelines for grounding and bonding electrical systems, including separately derived systems. The code emphasizes the need for a low impedance path to ground, which is achieved through proper bonding techniques. Bonding involves connecting all non-current carrying metal parts of the electrical system together, such as equipment enclosures, conduit, and building steel. This creates a network of interconnected conductive elements that provide a continuous path for fault currents. The size of the bonding conductor is determined by the size of the service conductors, as specified in NEC Table 250.102. C1. The bonding conductor must be large enough to safely carry the maximum fault current that could occur in the system. The location of the bonding connection is also crucial. As mentioned earlier, the bonding conductor should be connected as close as possible to the source of the separately derived system, which is the 200 amp breaker in this case. This minimizes the impedance of the bonding path and ensures that fault currents can be quickly and effectively cleared. In addition to bonding, grounding is another essential aspect of electrical safety. Grounding involves connecting the neutral conductor of the electrical system to earth, providing a reference point for voltage and helping to stabilize the system. The grounding electrode system typically consists of one or more ground rods, ground plates, or connections to underground metallic water pipes. The resistance of the grounding electrode system should be as low as possible, ideally 25 ohms or less, as specified in NEC 250.56. A low-resistance grounding system ensures that fault currents can be effectively dissipated into the earth, minimizing the risk of electrical shock. In the case of the fitness gym, the broken ground wire to the ground rod at the exterior breaker was a significant safety hazard. This broken connection compromised the grounding of the separately derived system, potentially exposing individuals to dangerous voltage levels in the event of a fault. Repairing the broken ground wire was a critical step in restoring the safety of the electrical system. The National Electrical Code also addresses the use of surge protective devices, or SPDs, to protect sensitive electronic equipment from voltage transients caused by lightning strikes, utility switching, or other disturbances. SPD are designed to divert surge currents away from the protected equipment, preventing damage to circuit boards and other components. Installing an SPD at the main breaker feeding the treadmills would provide an additional layer of protection against voltage surges, which could be particularly beneficial in an area prone to thunderstorms. When selecting an SPD, it is important to choose a device with an appropriate voltage rating and surge current capacity for the application. The SPD should be installed in accordance with the manufacturer's instructions and should be properly grounded to ensure effective operation. In addition to the specific issues identified at the fitness gym, it is also important to consider the overall condition of the electrical distribution system. Older electrical systems may have deteriorated insulation, loose connections, and other problems that can increase the risk of electrical hazard. A comprehensive inspection of the entire electrical system should be conducted to identify any potential safety concerns. Any deficiencies should be promptly addressed to ensure the safety and reliability of the electrical system. Furthermore, regular maintenance of the electrical system is essential to prevent future problems. This maintenance should include periodic inspections, testing of circuit breakers and ground fault circuit interrupters, and tightening of connections. By implementing a proactive maintenance program, potential problems can be identified and corrected before they lead to failures or safety hazards. In summary, the bonding and grounding of separately derived systems are critical for electrical safety. The National Electrical Code provides detailed requirements for these systems, which must be followed to ensure the protection of people and property. In the case of the fitness gym, the bonding of the neutral bar to building steel at the problem panel was a correct measure that complied with the NEC requirements. However, it is important to verify the proper grounding of the system and to consider installing surge protection to further enhance safety. Regular inspections and maintenance of the electrical system are also essential to prevent future problems. The National Electrical Code, or NEC, is a comprehensive set of standards that govern the safe installation and maintenance of electrical systems. It is updated every 3 years to reflect the latest advancements in technology and best practices. Compliance with the NEC is essential for ensuring the safety of electrical systems and preventing electrical hazards. Article 250 of the NEC is dedicated to grounding and bonding requirements. This article provides detailed guidelines for establishing a low impedance path to ground, which is essential for clearing fault currents and preventing electrical shock. The NEC also addresses the specific requirements for separately derived systems, such as the one feeding the treadmills. These systems require special attention because they introduce a new source of power that is electrically isolated from the main service. The NEC requires that separately derived systems be properly grounded and bonded to ensure that fault currents can be safely conducted back to the source. In addition to Article 250, other articles of the NEC may also be relevant to the electrical system at the fitness gym. For example, Article 300 covers general wiring methods, including the installation of conductors, cables, and raceways. Article 310 covers conductors for general wiring, including the ampacity ratings and insulation requirements for different types of conductors. Article 408 covers switchboards and panel boards, including the requirements for overcurrent protection and grounding. Compliance with all applicable articles of the NEC is essential for ensuring the safety and reliability of the electrical system. In addition to the NEC, other standards and regulations may also apply to the electrical system at the fitness gym. For example, local building codes may have additional requirements for electrical installations. It is important to consult with local authorities to determine which standards and regulations apply to the specific project. Proper bonding and grounding are not only essential for safety, but also for the proper operation of electrical equipment. A properly grounded and bonded system helps to reduce electrical noise and interference, which can improve the performance of sensitive electronic equipment, such as the circuit boards in the treadmills. In addition, a properly grounded system helps to prevent voltage transients, which can damage electronic equipment. Voltage transients can be caused by lightning strikes, utility switching, or other disturbances. Surge protective devices, or SPDs, can be used to protect electronic equipment from voltage transients. SPD are designed to divert surge currents away from the protected equipment, preventing damage to circuit boards and other components. It is important to select an SPD with an appropriate voltage rating and surge current capacity for the application. The SPD should be installed in accordance with the manufacturer's instructions and should be properly grounded to ensure effective operation. Regular maintenance of the electrical system is essential to prevent future problems. This maintenance should include periodic inspections, testing of circuit breakers and ground fault circuit interrupters, and tightening of connections. A proactive maintenance program can help to identify potential problems before they lead to failures or safety hazards. In addition to the technical aspects of bonding and grounding, it is also important to consider the human element. Electrical work should only be performed by qualified and experienced electricians who are familiar with the NEC and other applicable standards. It is important to follow safe work practices and to use appropriate personal protective equipment when working on electrical systems. Electrical safety is everyone's responsibility. By following the NEC and other applicable standards, and by implementing a proactive maintenance program, we can help to ensure the safety and reliability of electrical systems and prevent electrical hazards. To recap, the key takeaways are: firstly, the panel feeding the treadmills is a separately derived system requiring proper bonding to building steel per NEC 250.30. Secondly, the bonding conductor should be as close as possible to the 200 amp breaker for minimal impedance. Thirdly, a second ground rod is not mandatory if the existing one is effective. Fourthly, bonding to building steel is not a backup for the neutral conductor. Fifthly, bonding the neutral bar to building steel at the panel is a correct measure. Sixthly, verify the ground rod's connection and resistance at the exterior breaker. Seventhly, inspect the entire electrical distribution system for proper grounding and bonding. And eighthly, consider installing a surge protective device to safeguard the treadmills. Proper grounding and bonding are fundamental for electrical safety and equipment protection.